Dmitry Kochergin, head of technical support, will tell us now about the current state of PHOTOMOD 6.0. Dear colleagues, the subject of my presentation is PHOTOMOD 6.0, the current state and prospects. As you know, that we released 6.0 last year in fall. It continues to develop naturally. Some changes have occurred to date. So first I'll tell about PHOTOMOD 6.0, then I'll describe changes between the available version 6.0.2 and 6.0, and then I'll talk about what's coming next. So let's start with 6.0. First thing worth mentioning is that it is the first full 64-bit version. Before that, we had 32-bit because Borland did not produce a compilator. This is the primary achievement of the version. And then we go item by item. Unique dense DSM creation algorithm, radical increasing of data volumes, multiple speeding up of block adjustment calculators, and also PHOTOMOD UAS plus processing of data from UAS, unmanned aerial systems. Why is 64 bits better than 32? It's better because you can use the fullness of storage. So you can control how much you use. Of course, this is a much greater advantage than 32-bit architecture. And that immediately provided advantages and benefits. Let's say you have 48 gigabyte RAM, random access memory. You can increase all the numbers, all the parameters. PHOTOMOD projects up to 100,000, GeoMosaic 100,000. Bundle adjustment. It's basically the same. Previously you could do 10,000 images, now it's 100,000 images for aerial survey and satellite imagery. And this is based on 48 gigabyte RAM, so you can enhance even that. As for digital terrain model, once again, we're talking about dozens of millions of points. And this started to actually move quite well when on screen. Now, talking about unmanned aerial system, BPL-A or BPL-S. So this is standalone software at special price. It was primarily a commercial move. In fact, it's a functional PHOTOMOD, which costs much less. Image size is limited to 60 megapixels. Plus, the interface was simplified so that users would only use the necessary buttons. Now, what are the changes? In fact, these are the changes over the year, and they relate to UAS image processing. We now have these options. They're interested to those who know their way around PHOTOMOD. The idea is very simple. You have a point on the left image and it is transposed to the right image. Then from the right image it gets transposed to the left image. And if during repeated transposition points match, then you have a hit. If we want to have more accurate and reliable measurements, we can set 4 and not 1 as set by default. There is a new calibration module, a mixed one. Basically, it has more factors and parameters, and the results are more reliable. Because for UAS, calibration is a necessity. Subsampling is a very useful thing. In many cases, there are a lot of redundant images. But here, you can subsample it. In other words, remove the images with sharp angle of cut-on or great angles of roll and pitch. And with that, we do not lose any accuracy. For satellite imagery, now we have type points filtering. Even though there are some things that we need to finish here. Also, DEM transformation has emerged. So you have a DEM, you have a bundle that you adjusted. Previously, you could only do it for vectors. Now you can also do it for DEMs. As for localization, we've made a lot of progress. Now we have English, Russian, Chinese, Greek, and obviously Spanish, which is most importantly for this audience. This is what has been done. Now let's look at what is coming, what's in the testing stages. First of all, we have done another version of feature-based correlator. Again, it's going to be used for UAS. First of all, for bad survey situations where you have bad angles and the lighting is not right, it can come in handy. So you use filtering, which leaves you only with good points, and that will lead to complete and irrevocable automation for UAV-based images. We still have a problem with forests, though. Its results from DMC. Like I said, it's going to be mainly used for unmanned aerial systems. But it does not mean that you cannot use other sources. So in this particular case, we ran a test and it took us through 3.5 hours to perform the task using one core. But you can expedite it and do it 5 times faster on CUDA. You could also use triplets, duplets, depending on how many images you have in the overlap. This is a good example for UAS. You can see there's a multiple number of overlaps, overlapping images. So then you measure the points by filtering. This is another example of UAS block. We use block layout. And this is an example of what we talked about already. A new DSM creation algorithm is almost done. We nearly implemented SGM, mentioned by Mr. Lemons. This is a very popular algorithm, and the early results are very inspiring, but there will be a separate presentation on that. Also, we almost have a new color balancing tool which was tested on some production projects in the Crimea. And soon it will be provided to end users. Well, that about does it. That's all I wanted to share with you about 6.0 and 6.0x. Do you have any questions? 6.02 is already out. As for the newer version, color balancing is nearly done. I think we're talking several weeks. And the other elements, they should be completed by the end of this year. I mean SGM and feature-based. You will soon be able to download some of it and play with it. I have a brief question. You described triplets, various triplets, all sorts of plets. This is a relevant subject for multi-directional survey. Many do it. It's important for DSM too. Have you researched the reliability of generating type points, or DSMs in this case, as a factor of resection angle? Of course, when it comes to DSM, the greater the angle, the bigger the error. Sometimes you can get varying results, and you even begin doubting if correlation will be proper. Do you have an automatic filtration in place? We don't at the moment, but it's something to work on. Because once again, in case of UAV, it's a problem. There is a 95% of overlap. Filtering will take ages, and the computer will have to work really hard. I'll talk a little bit about type points. First two examples with 300,000 points on the UltraCam and several thousand points for UAV. Some rough areas are being quickly removed. And actually there is no dependence to angle. UltraCam and DMC are vertical cameras. With UAVs, it was twice as bad. If you make a half pixel error, yeah, maybe, but that's a different story. Even though I digressed a little, I wanted to make this addition.
It seems there are no more questions, Dmitry. Thank you very much.